This is part 2 of my actual philosophy in my book, or from my book, Causation and the Universe, a bridge between the 1900s and the 2000s. I call this "The next sentence is true, the previous sentence is false." And I ended with a quotation from last time. So I'm going to continue here. So, we have two statements. 1. A means that A is unprovable. And 2. False formulas are unprovable. One can easily replace one with either false A is unprovable or true A is unprovable. A means that A is unprovable can only devolve upon that A is unprovable. Because to say A means that is just an added appendage to saying this claim A is unprovable. So the full sentence, A means that A is unprovable, is a predication in which A is either true or false, or either true or false. Unprovable means that something cannot be proved true. So we come to the question of not A, i.e. false A. 3. A means that A is unprovable, if false A or if true A. 4. False formulas are unprovable. We cannot initially put an equal sign between the premise A means that A is unprovable and false formulas are unprovable, because we do not yet know if A is false or true. The following are all 4 heuristic possibilities for a theorem which I am going to examine very shortly. A equals false and provable. Since A cannot be false and provable, I will leave this sentence aside. A equals true and provable. If A is true and provable, it does not contradict false formulas are unprovable, number 4 above, and hence true and provable is still valid, and thus also is independent from 4, which is rendered superfluous. A equals false and unprovable. False A means that false A is unprovable. It's a true proposition. It does not contradict with 4. A equals true and unprovable. And of course, if A is true and unprovable, it does not contradict 4, because true A is supposedly just unprovable, for now anyway, and not false. Remember that is unprovable means that something cannot be proven true. Unprovable does not mean that A is both not true and true at the same time, or even undecided, because that is impossible anywhere but in quantum mechanics. A true proposition cannot be unprovable, and a false proposition can never be proven true. A false proposition can perhaps be proven false, but it would still not contradict 4. Someone may suggest that we must transform the formulations above into basic math rules like this, and strip it of digits. Minus plus equals minus or imaginary. Plus plus equals plus or true. Minus minus equals plus, true. Plus minus equals minus, imaginary. The following is an explanation of what I'm claiming here. A. We would get minus plus equals minus, imaginary, if A could be false and provable, which it cannot. False propositions cannot be proved true. B. We get the formula plus plus equals plus true if it is true and provable, which certainly wouldn't conflict with 4. C. We get minus minus equals plus or true if it is false and unprovable. And finally, D. Thus we get the formula plus minus equals minus, imaginary, for the true and unprovable. I realize that labeling unprovable as a negative equaling with false by assigning it to the negative minus, when true represents the solid plus, can open up for an interpretation of the above 4, A, B, C, and D, as erroneous thinking all in all. Because false A is unprovable means that false A cannot be proven true, but false A can still be proven false, which seems to correspond with the negative minus much better. And that would have been correct if it hadn't been impossible to prove false A true, as we have accounted for in and above the deterministic expressions. So what we are left with is that false A can never be proven true. That is, false A or minus must always be followed by minus for unprovable. And that means that this proposition, minus minus, is true. A true proposition cannot be unprovable, and a false proposition can never be proved true. In the original theorem, it is claimed A means that A is unprovable. That means that A cannot be positive, plus, if unprovable is minus, since true A cannot be unprovable. Because everything true is provable, and plus minus equals imaginary, not true. Therefore, A equals not A equals minus A. And the formula must read minus minus equals plus or true. False formulas are unprovable, wherein the false formula equals minus and unprovable equals minus. Therefore, minus minus equals plus equals true. Even though unprovable is a factor in the proposition, there is no contradiction. The important thing is that the plus indicates existence, and the minus is indicating non-existence, so that the result equals one of two things, true or imaginary. For the fun of it, one can maintain that this is the explanation of why the universe exists, and that it is a God proof as well. Let us assume that minus minus represents the two unexplained fundamental entities, the universe and God. Since 2 non-existing of anything, minus minus, equals plus, i.e. a positive number equals plus, the universe and God are destined to exist, however unlikely they seem to be. In fact, the improbability of their existence separately could be a precondition for their very coexistence. Minus God minus universe equals plus existence. And if it, math, is a precondition for their very coexistence, then the existence of the universe and God suddenly seems very plausible. And if either the universe or God fails to exist, the result is that neither of them exist. Plus minus equals minus. But we exist. We exist, and therefore God exists. But is this God proof conclusive? Of course not. No God proof is conclusive. I'm just having fun. They use the words similarly in both German and English, except they make one word out of nicht beweisbar in the English language, and that is interpreted unprovable in English. But that does not change my argument. Sind and nicht are interpreted is and isn't, or are and aren't, in my argumentation. A meint, dass A nicht beweisbar ist. Falsche Formeln sind nicht beweisbar.